Okay, now we're going to kind of get into some of the details with this present example. I like to use the alcohol and pills example because I think it's a good real-world example. Do you know that obviously you shouldn't be mixing benzodiazepine, Xanax, with alcohol? That's a really bad idea. So let's take a look at this data set. The first thing we'd want to figure out is how many people do we have in this data set? Well, in a 2 by 2 factorial, since we have 3 people in each cell, there are 3 different people in each cell, so this is a total of n equals 12. And if you look at the scores here, for the people that got no Xanax and no beer, their scores on a motor performance test, maybe it's walking 100 steps or something, they got scores of 100, 100, and 100. If you look at the people who got no alcohol, no beer, but they got 50 milligrams of Xanax, those 3 people got scores of 75, 80, and 85. If you look at the people who got 72 ounces of alcohol and no Xanax, their scores were 78, 80, and 82. And finally, if you look at the people who got the alcohol and the pills, what do you notice about that group? Scores were very low. Why? Because you're really not supposed to mix alcohol and pills. Their scores were 15, 20, and 25. Now, the first thing that you should probably do with this matrix, if you really want to understand the effects of things here, is you should probably get the means for each of these groups. So what would be the mean of the no fun group, the no beer, no Xanax group? Well, if you want to put in parentheses after the hundreds, just the parentheses of 100, that would be the mean score for no beer, no Xanax. What would be the mean score when people got no beer and got the Xanax? Well, that mean would be 80. What would be the mean when people got 72 ounces of alcohol and no Xanax? That would also be 80. And then finally, what would be the mean when people got both the alcohol and the Xanax? Well, that mean would be very easy. That would be 20. So you should probably put those in parentheses. And those are things that you should just basically know. So let's go down to the next part of things here. And we'll get to the marginal means in a minute or two here. But 3 issues that you basically always want to answer when you have a 2-factor ANOVA, even with the examples above. There are basically 3 statistical effects you can look for. One of those effects is called the main effect of variable A. In this case, you could look and see, is there a main effect of alcohol? A second question you can look for is there a main effect of pills? And then the third question, is there an interaction between the alcohol and the pills? So with any 2-factor ANOVA, there are 3 effects that we can basically look for. A main effect of alcohol, a main effect of pills in this case, and an interaction between alcohol and pills. So the way that we actually do this is we'd actually have to put these numbers in these data sets into SPSS, but there are some simple ways that we can look at the data set to basically figure out if we're going to actually have significant effects. The first question here, is there a main effect of alcohol? The way we have to look at that question and what you want to write for the notes here to assess if there's a main effect of alcohol, you basically look at what is the mean when people have no alcohol versus what is the mean when people have alcohol. And what you actually have to do is you have to average that across the Xanax. So if you're looking for a main effect of alcohol, you basically have to compare what is the mean with no beer to what is the mean with 72 ounces of beer. And what you basically have to do is you have to get the marginal mean when people have no beer. So what is the mean in this case when people have no beer? You have to take the mean of the no Xanax, no beer group, 100, and you have to average that with the mean of no beer with Xanax, which is the 50 milligrams. That mean is 80. So the marginal mean of no beer would be what? 90. And then what you have to do is you have to say, well, what's the marginal mean when people have 72 ounces of alcohol? Well, the mean of the no Xanax, 72 ounces, is 80. The mean with the 15 milligrams of Xanax and 72 ounces is 20. What's the mean of 80 and 20? The marginal mean is 50. And so if you have a marginal mean of 90 and a marginal mean of 50, when you put those numbers into a statistical program, that difference is pretty large. And the fact that that difference is pretty large, the 90 versus the 50, will probably lead that result to be statistically significant. So there'll probably be a statistically significant main effect of alcohol, which will basically say that when people have alcohol, performance is a lot lower than when they have no alcohol. Notice here we're not talking at all about Xanax because it's a main effect for one variable here. So one variable you can talk about is a main effect. Now let's go into the second example. Is there a main effect of pills? In order to answer that question, you have to say, well, what are the different levels of pills? We've got no Xanax and we've got Xanax. What is the mean if you go across the matrix? Couldn't write it in. What is the marginal mean when people have no Xanax? Well, no Xanax, no beer is 100. No Xanax and 72 ounces of alcohol is 80. So the marginal mean of no Xanax is 90. What is the mean when people, the marginal mean when people have Xanax? It's 80 for the one group, it's 20 for the other. So the marginal mean there is 50. And so when you do the statistics, you'll probably find a statistically significant main effect of pills. The real world conclusion would be when people get the pills, performance is worse. So these are how you actually look and evaluate if there are main effects. Your book also talks about this, but when you're looking for a main effect, you're basically looking to evaluate what's the effect of one independent variable when averaged across the second one. And so in this case, we would look at no beer and beer, average across Xanax, and then we'd look at no Xanax and Xanax to average across the beer. Hope that makes sense. Thanks. Bye-bye.